All right, everybody, good morning. Welcome back to class. Just a few minutes till 11:30, and then we will get the meeting underway and get a little more practice on some of these logic problems. So I hope you guys are doing well and had a great holiday. I'm just going to stick to about 4 minutes, but anybody who's here, thanks for being here. As always, feel free to say hi or anything in there in the chat. Hi, Leo. Hope you're doing good. Hey, Nathaniel and Valeria, good to see you guys. Marissa, Rachel, always great to check in with everybody here. Hi, Dronred. Hey, Melanie, good to see you too. Just about 3 minutes. Had a good Thanksgiving, yeah. It was just me and a very small gathering of 3 people who I often see anyway, so it's not like I went and traveled. Yeah, we didn't have the full big gathering that we would normally have, but just a couple of us, and it was really good. Nice meal, and a good chance to just kind of take a break and reset for the last few weeks of the semester. Hey, Jamie, good to see you. I still have a bunch of pie and stuff, so Thanksgiving continues in a way over here. A lot of leftovers. Hey, Ruby. My grandma's name was Ruby. I always think of her when I see her name. I had a very close relationship with her. My mom's name is Robin. So it's like Ruby, Robin, Richard, the 3 of us. Anyway, fun fact. Hey, Yvette. Okay, guys. Well, it's more or less 11:30 now, so welcome back, everybody. Hey, Brenna. Today we're just going to do a little more practice and get a little more prepared for your 4th homework. It's due in 1 week, and also for the final exam that happens during finals week. So I thought one thing I could do to help you guys a little more. We've gone through one of the homework problems as a group in a previous meeting. I don't want to reveal the answers to all of them, obviously, because I want you to have a challenge. But I thought it would be okay to maybe just do one more of the practice problem, well, not practice problem, but homework problems as a group. As long as there's good group participation, I can guide you through one more, and then we'll at least be clear on 2 of the answers. Hey, Karina, good to see you too. So I don't know if anybody wants to suggest one of the problems to attempt. I see, Tanya, you're on board with this idea, but if there are any questions or particular problems where you found that you'd like to have a little more help, then probably the tougher one for you would be the one to look at. I don't know. But is there a suggestion? Otherwise, I could just throw one out. But I figure you'd have a sense of perhaps, or the group might have a sense of which question, if any, that you'd like a little more help with. So Brenda, you say 7 or 10. Okay, let me quickly look at this list. Now, I mean, number 7 is very easy. I don't know if I should do that one, so easy, but number 10 is pretty hard. So we can take a look maybe at number 10, if that's cool with everybody. Brenda, you thinking 10? Everybody else, I mean, has anybody actually finished number 10? If so, then they probably wouldn't want me to do that one, but is there a second opinion at all, or are we all good on just maybe working through number 10, the last one on the problem sheet? Are you guys up for that? Let me get some feedback from you, number 10. Because I've seen one suggestion. I'm inclined to go with it. Okay, Jessica, you're feeling good about it. Amory's same. All right, then let's do that. Let's go ahead and work through number 10. So what I'm going to do, we'll see if we need to switch over to the Zoom dual format. I'll do that if we start looking into the book after we finish number 10. But for now, because I can display the question on the board here, I'll hold off on sharing the Zoom link. And if we do need it, then we will get into it after we finish this problem here. So let me show you the problem on the board. What number 10 says is, so this is homework number 4, problem number 10. And the instruction is, derive that if A, then E. That's what you have to derive. And here you have 3 premises that start the problem. 3 assumptions. So the first one is that if A, then either not B or C. And for number 2, if A, then B. And then the third assumption is neither C nor D. So tilde parentheses C or D. It's neither C nor D. And what we want in the end here is this statement that if A, then E. Okay, so we're going to take it slow, but we'll get to the answer. So let's think about how to start this problem, okay? Well, first question is always this. What kind of sentence is the goal? What kind of sentence? What's the terminology of what's the type of sentence that we want in the end? It's known as a what? It's a conditional. Good, Karina. It's this conditional. It's the conditional that says if A, then E. So who could tell me what is the best rule to apply when you're trying to build a conditional? You want a conditional, so what rule is often used there to establish a conditional? Keep in mind there's 11 inference rules that we know, and there's 2 for each connective. One is an introduction rule, and one is an elimination rule. So Leo, you're saying conditional introduction. Okay, good. So if I were to do conditional introduction, then what would be the information that I would write on line 4? Who could tell me what line 4 should say if we're going to now pursue this conditional introduction rule? So I'm helping you a little bit by telling you how to get started, or at least directing you to the right way to start, which is conditional introduction. But how does conditional introduction work? What is the inference that one would make? So Karina, you say assume A for conditional introduction. Good. Okay? We've assumed A. Let us know and remember that when you do conditional introduction, you're trying to eventually get a full conditional statement. And what you have to do in the beginning is you assume the antecedent term or statement, thing that's on the left of the arrow or the horseshoe symbol. The antecedent is on the left of it. So you assume that, and then through inference, you eventually have to get the letter E to appear inside of this subderivation. Yes, Evelyn, we assume A because it is the antecedent of the desired conditional. The desired conditional, the desired statement is whatever you are told to derive. So here you've been told to derive this thing specifically, A, then E. That is a conditional, which has the information if A, then E. So when we introduce a conditional, we assume the antecedent, and then through inferences, we eventually try to establish the consequent. That's when the conditional introduction will close the subderivation, and we will just be able to write A arrow E, and we'll be done. So ultimately, our goal is to somehow get to E through these steps that we see on the board. But we're not there yet. So far, we just have A. So anyway, then, since A has now been assumed, what do you think could be done next? With each new line on the proof, you have to basically examine what has been there previously in conjunction with what has been added in the previous line. So Lily, you say tilde E, and that will come from a negation elimination assumption. Okay. This isn't the method that I used to prove the problem, but let's see if that works. I don't know. So Lily, you're saying, assume here tilde E, and do it for negation elimination. Okay, so in that case, we have a second subderivation, which starts with tilde E, and you're trying to find some contradiction here. But to be honest, Lily, I'm not so sure that this method is going to be so easy to do. Let's see, though, if it works. What will be the next step then? What do you think could be the next step? Well, I guess to be fair, there is some need to do this tilde E thing eventually. As I look at my order of steps, I think I just did it a little later than you did. So not to worry, but as we know, there's a way of doing a certain problem with doing steps in different order. So Lily, you suggest that we now do conditional elimination involving line 1 and 4. Can we all see this, guys? So look at the problem. Line 1 is that if A, then this parenthetical statement. If A, then either not B or C. Line 4, we have assumed A, and we've done this for conditional introduction. That means that A is now available for use. And since conditional elimination requires a conditional statement and the antecedent, we can do conditional elimination on 1 and 4. And that establishes this consequence. So tilde B or C. Conditional elimination 1 and 4. So tilde B or C is inside of this subderivation. Now keep in mind, everybody, that within this subderivation, this second subderivation, what is the inference that starts it? Well, it's negation elimination, which means that we're going to have to get some kind of contradiction in here in order to discharge that assumption and close the subderivation and get E. But okay, line 7. Even if we're not sure what's going to be at the end of this proof, we can always infer line by line. I mean, so there's still an inference that we can make now that hasn't been done yet that we can add onto line 7. So what do you think? Line 7, just applying an inference rule using the above 6 statements. And you can think of patterns, like you've seen that we used 1 and 4 to do conditional elimination. And it's possible to do other cases of conditional elimination as well. So Leo, it seems that now you're seeing that. We'll do conditional elimination on 2 and 4, and that produces B. Very good. Okay, so there's B now. So, Lily, did you have an idea at this point? So you're saying tilde B is assumed for disjunction elimination. All right. So we're going to have a third indented subderivation here, because now we're going to, I guess you're saying, assume the two sides of this disjunction. We have a disjunction now sitting on line 6. We did not have a disjunction sitting anywhere until we had line 6, because before we just had conditionals, negation, and so on. So you're saying do disjunction elimination then. Tilde B assume for disjunction elimination. Okay, so now that we've assumed tilde B for disjunction elimination, we have to find a common result from tilde B, and then after that, the same common result from C. So what should this common result be, if anything? Is it possible to then say, you're saying, Lily, tilde B by reiterating 8? Yes, you can. So I guess what you're looking towards is to get tilde B from both of these. Then that will contradict B. Then that will establish that E. Then we will be done. Okay, so I see the method that you're now pursuing. So on line 9, tilde B is reiterated from the previous line, 8. So now that means that by assuming the left disjunct, we got the result tilde B. So when we do disjunction elimination, we have to make a secondary assumption after we get one result from the left disjunct. We then have to assume the other right disjunct and establish the same result from it. So what is the right disjunct of the disjunction that we just started to eliminate? I'm asking that question. What is the right disjunct of the disjunction statement that we are eliminating? Okay, good, Karina, it's C. Meaning that on line 10, we should do what? So you told me what the other disjunct is, good. But keep in mind the procedure that we're now in the middle of, disjunction elimination. So there's two parts to disjunction elimination, and I would just love it if someone could just tell me what the exact information is to write now on line 10 to continue doing disjunction elimination. Just what to write on line 10 and what rule to cite. Leo, good. C, and we assume that for disjunction elimination, but you don't have to write any number. It just refers to line 6. Okay, now, we're on to line 11. What is the goal of this C subderivation? The goal of the C subderivation is to get to the same thing as we did from tilde B. And what is that? Ultimately here, we would like to get to what result, having assumed C? This is just a sort of question about how disjunction elimination works. Not tilde C, Frida, no. It's tilde B. We're trying to get to the same result as the other disjunct. So disjunction elimination works by means of assuming one disjunct, showing a result, then moving on to the other one and showing the same result. So we're going to have to eventually establish tilde B here within the scope of the C subderivation. Okay then. So what then shall we do next? Lily, you're saying let us do yet another case of assume B for negation introduction. Okay, so I'm going to have to continue the problem on the right side here because of the space limitations, but we'll do that, not to worry. On line 12, We've now assumed B for negation introduction. That requires us to somehow get a contradiction in there. And if we do that, then we'll have tilde B here. And we'll have our common result. Okay, so what's the contradiction that we could possibly get here? What could that be? We've got, looking at it above, B, tilde E, C. But I'm thinking now, I mean, Lily, you may have to, so you say C or D from disjunction introduction on number 10. Very good, yes. So look at C here on line 10. That's just a single sentence letter. When we use disjunction introduction, we can disjoin something to an already existing line. C is line 10. So we can disjoin to it the information D, C or D. That's disjunction introduction of line 10. Okay, so here's C or D. Now, we need to get a contradiction. And if you look above, you actually should be able to see something here that is available to use as a contradiction. So what is the contrary of C or D? Anybody who could tell me that? What is the opposite statement, the polar opposite of C or D? What is the opposite of that? This is a question just about the reverse of C or D. Close, Karina, I think you have a typo. Do you mean to say tilde C or D? That's what it should say. C or B, different letter. But I think we're on the same page, right? So the opposite of this, which says C or D, is tilde C or D. Now look above on all these lines. Is there any line where you see that statement written? If so, just tell me where it is. It is line 3. So then, what should we perhaps do to get our contradiction in? Good, good, thanks, that's true. Line 3 does have the statement tilde C or D. So if you're following the logic then, and you understand this rule that we've now started with, negation introduction, you should be able to tell me what I should write on line 13 then. In the interest of closing this subderivation, this negation introduction subderivation, what could it be? That one I gotta wait for you. I don't want to tell you this, but you should see it. It's not that much of a leap in logic or thought. I mean, you have to have a contradiction, and I'm really, really dancing all around telling you exactly what it is, but okay, good, Jessica. Tilde C or D, reiterate from line 3. That's line 3. Let's bring it down here so that it sits next to this other thing, which is its opposite. Tilde C or D. Reiteration of 3. That's what that says down there. Now I'll continue the next line over here. And I guess I'll need 1, 2, 3, 4 scope lines. And outside the scope of the fourth one, 1, 2, 3, 4, we're going to have the result of closing the subderivation down. Okay? So what is the result of closing this subderivation now that we have the contradictory pair? Oh, sorry, let me look above here. Tilde C or D. Well, it's reiteration from 3, Marissa. There's no negation elimination cited there. And then line 12, you ask Karina, what does line 12 say as the rule? Line 12 says disjunction introduction of 10. And so Tanya helped you there, good. So Leo, you seem to now understand that tilde B is the result on line 14, because when we close this subderivation, it spits out the opposite of the negation assumption that we started with, which we started with B. reversing that is tilde b. So over here, tilde b, and that is from negation introduction. Sorry, let me get this a little closer to the left. Tilde b, negation introduction, and the numbers in this case are what? Just tell me the numbers to cite while I'm closing this b negation introduction assumption. I don't know, you gotta tell me. Just gotta give me some numbers that I have to cite in order to justify closing that subderivation. Okay, Arlene, very good. It is 11 through 13, 11, 12, 13. That's the little series that started with B, followed by having two contradictory statements there. So it is 11 through 13. I'm trying to make this a little bit better, sorry. Okay, that just says 11 through 13, negation introduction. So now we are on line 15. And I know visually it's a little disjointed, but if you see above, okay, this has been a closed subderivation, which resulted in tilde b. But we still have this subderivation open, the second part of disjunction elimination. Well, notice that tilde b is the statement that's within this subderivation now, and that's what we wanted. We got tilde b here from tilde b by reiteration. We also have tilde b from the other disjunct, C, by means of making that assumption and then doing negation introduction. Okay? So, if we've reached tilde b from both of these two disjuncts, that means we've basically reached the end of the road of disjunction elimination for that proposition. So what should be written on line 15 as we are now closing the disjunction elimination? Think of the rule of disjunction elimination. The way that it works, just as a reminder, is you find one result from one disjunct. Then you move on, and however long it takes, you get the same result from the other one. When you have found the same result from both, then you write that same result once again outside the scope of the closed subderivation. So I've told you, and I think you can see it, what the common result is from these two sides on line 6. That's what we have to write on line 15 together with the justification. So I just have to ask you, what shall I write on line 15? There's only a few more steps. But yeah, line 15. It's just the rule of disjunction elimination. So Karina, you're telling me the justification, but you're not telling me the sentence to write. That is the right justification, correct. But the sentence that we are justifying there, correct, Arlene, it's tilde b. Same, good, Nathaniel. That's disjunction elimination, line 6, comma, so 6 where the first disjunction occurred, then the two dashed series, 8-9, 10-14. Okay, so now we are on line 16. And if you look, we have tilde b finally occurring in this subderivation. The whole point of doing this long detour into disjunction elimination was basically to get tilde b, all right? And we now did do that. So we have tilde b inside of the scope of this negation elimination assumption. Thinking of negation rules, what you have to remember is that they involve finding a contradiction, okay? So is there any contradiction that exists inside of this subderivation that starts on line 5 and that spans all the way through to line 15? Can you see the lines that I'm referring to in between 5 and 15? Look at each line and tell me, do you see two things there that are opposites? If so, what are they? What are these opposite statements that exist inside of this long subderivation? That's what I need you to tell me. What are the two things that are in there that are opposites? Well, okay, Karina, you're saying 8 through 9 and 12 through 13. But no, statements have to just be on two individual lines. One line has one and another line has another. Lily, you say 7 and 15. That is correct. Karina, can I draw your attention to that? Look at 7. You see that that's B, right? And look, we did all this work to build up to line 15. And what does line 15 say? It says tilde B. Okay, so B and tilde B are opposites. They contradict. So since they are both inside of the subderivation, that allows us to close that subderivation. And now you'll tell me the result of doing that on line 16. So what's on line 16? Line 16 is the result of closing this subderivation because we did find a contradiction, namely B and tilde B. Okay, great, Lily. So that is E, based on negation elimination 5 through 15. Negation elimination 5 through 15. Now we are on line 17. Okay. And what about line 17? We've got this subderivation that started on line 4, where we assumed A. Now, quick reminder or refresher. How does conditional introduction work, everybody? What allows you to close conditional introduction as a subderivation? Like suppose, for example, let's take a different example. Suppose that you were trying to prove in a problem A arrow B, okay? And you started that by assuming A. When would you be able to close the subderivation and write the full statement A arrow B? In a subderivation such as that, where the goal is A arrow B, and you introduce A in a subderivation assumption, at what point would you finally be able to close the subderivation and write down the desired statement? Just basically, how does conditional introduction work? I want a precise statement of that, and then I'll redirect us to this problem one more time. So when you get to B, good, Jessica, exactly. So subderivation of conditional introduction is you assume the left side of the arrow, and then however long it takes, you eventually try to get on a numbered line the right hand information. In this case, that would be E. Now, have we done that? Did we start with an assumption of A for conditional introduction and eventually arrive at the goal of E? Have we done this? Yes or no? Yes or no? Have we completed the procedure of assuming the left antecedent and eventually establishing the consequent? Correct, yes, we have. So that means we are now in position to close the subderivation. So that means you can tell me what is line 17. What is line 17? All the pieces are in place. Just have to put that last step together. Line 17 is the closure of this conditional introduction subderivation. And there's only one possible way to ever close conditional introduction subderivation, by writing the relevant antecedent and the relevant consequent. So good, Arlene. It is A arrow E, conditional introduction. You should have the letter I there, but that's okay. Conditional introduction 4 through 16. And there is this problem in 17 steps. Looking back at my version of the solution, it's actually, it's funny, it's actually more steps. So Lily, I think you had a good intuition actually, because mine took 18 steps. I'm trying to see how it was different Um, yeah, it's like I did disjunction elimination first, and you did negation elimination first. So in my version of the problem, which actually did take one more step, so slightly less efficient, on line 5, I did conditional elimination on 1 and 2, like on line 1, and line 6 I did on line 2, so I had like tilde B or C and B standing here. And then I started to do disjunction elimination, separating tilde B on the left, and it was just a slightly different order of operations, but it resulted in the same solution. So it's another good reminder that sometimes we can take a few possible pathways to the correct answer. So this is number 10 of the homework problem set. Please note that it should be on one continuous page in your own version of the proof. It's not best to have it separated on 2 columns like this, but limitations of space necessitated that here. But I did try to make visually clear that if we carry the scope lines over here, then they mirror the structure shown above on the left. Okay, so I saw a question about number 7 as well. And I mean, we talked a little bit about theorems, but maybe for some of you, there's still a little bit of unclarity on the theorem concept. So I figure I can at least get you started on that problem. And maybe if you're able to solve it without much assistance from me, then I could at least verify a correct answer. But I really want to take it very easy on me contributing much of the answer to this number 7, because it's just a fact that when you understand how number 7 works, it's very simple, and there's only a couple of steps. It's like 5 or 6 steps. But let's go ahead and take a look at it, okay? So I'm looking at this theorem problem, number 7. It says derive that, okay, if A, then if B, then C, then if both A and B, then C. All right, so that is our problem here. And it's a theorem, meaning that you don't even have any premises, no assumptions are given. So just on line 1, you have to be the one that says what to do. So to anybody who has a sense of how to conduct this problem, let's first of all ask this big question. What kind of sentence is this that you've been told to derive? What kind of sentence is the goal sentence? The main connective, in other words, of the sentence written here shows us that it is a what? Okay, great, it's a conditional. It is a conditional, and so when trying to prove a conditional, the most typical inference rule is called what? By now, this is something I hope seeing a pattern, because we've done it many times, including just now. So to get a conditional, one should consider using the rule called what? The rule that builds a conditional. Conditional intro, very good, yes. So we just have to kind of get comfortable with the nature of this rule. When we're trying to build a conditional, we use conditional introduction. Now, let's go over this again. How do you do conditional introduction? You start by assuming what? To do this rule, you must assume initially what? Conditional introduction starts with an assumption, and it's the assumption of the antecedent. Correct, good, Tanya. So it's a little messy looking, but what is the antecedent of the conditional that you see here? What is that antecedent in this example? Just type out the full antecedent information for me. What could it be? It's written there. Can't miss it. You're looking right at it. So just tell me what you're seeing. What's the antecedent? A arrow, B arrow, C. Yes, that's correct. It's this whole thing that's bracketed on the left of that arrow. Okay, now you can tell that that's the antecedent because this letter A is only the antecedent of the conditional contained in these brackets. This letter B is only the antecedent of this little conditional that's contained in parentheses. This A and B is only the antecedent of this bracketed conditional to the right. So you look at this arrow as the one that connects the entire bracketed antecedent here with the entire bracketed consequent there. So you're very much correct. Good job, Karina and Valeria and Jessica. In other words, what we have on line 1 is this assumption that if A, then if B, then C. Assume for conditional introduction. So now, what is the next step in doing conditional introduction? When you assume the antecedent for conditional introduction, the algorithm is that you then have to eventually, through however many steps, obtain what on a line? On a subsequent line that comes later, what will we be able to use to close this subderivation out and finish the problem? Whenever we get to what part? Whenever we have a line with what information on it? What's the goal of conditional introduction? You can't be just flying blind. You can't be like, okay, as he says conditional introduction, whatever he says, I guess I'll do it, and I don't really know. No, you have to know. So what is the exact goal when you start by assuming the antecedent of a conditional? You move to the next point, which is to try and establish or show what information? Establish, no, that's not correct. You're trying to, okay, Arlene, good, you're saying that you want to get this. That's right, but the terminology for it, if we can just use that proper terminology, Arlene, that is the specific instance here, but in general, we say that we have to show or prove the consequent, yes. Okay, so consequent versus antecedent. Yeah, don't worry, Karina, it's okay. So this whole thing is the antecedent, and that is the consequent. So when this will end is whenever we get this whole thing on a line below line 1. But you have to then have like kind of tunnel vision, okay, and look at this consequent. What kind of sentence is that consequent? What kind of sentence is that? Just the consequent information. Or as Arlene wrote, A and B, then C. What kind of sentence is that? What's the main connective of the consequent? So yes, it's conditional. Good, perfect. Well, hold on, Brenna. Yes, we're going to do conditional introduction, but I'm taking it slow. I just wanted to ask everybody, what kind of sentence is this? And as you guys are pointing out, correct, that is a conditional. So we have a conditional within a conditional. The antecedent of the big conditional is if A, then if B, then C. The consequent of the big conditional is that if both A and B, then C. So since we are now trying to establish this statement within the proof, we have to use, once again, the same rule twice. So what is this rule that we must now use on line 2? Again, and now maybe some of the commentary I just saw will come in handy, but let's repeat it. The rule to use now on line 2, as we work to establish this second conditional, is what? There's a rule that now has to be used. This might be, I don't know, the part of the problem that's somewhat confusing to maybe a few of you, but it's really very much a set pattern. You have to establish a conditional within a conditional, and there's really only one rule that you can use to build this second conditional. And we keep talking about it, but what is it? Correct, yeah, tell me please, what's the rule to use as we continue through this proof? You all seem to understand that we assume A arrow B arrow C. Good. You don't have anything for me though for line 2? I mean, line 2, I'm telling you, you have to start now towards establishing this consequence, which is another conditional. So good, Jamie. Conditional introduction has to be used again. And that's correct. Good, Karina and Brenna. So let's assume the antecedent of the new conditional, which, as Valeria can tell, is A and B. So Jessica, almost, but it is to assume A and B because this conjunction here is the antecedent of this conditional. It is this information that's on the left of that arrow, not just the letter A, but A conjoined to B. So on line 2 then, we are assuming A and B. And that's assumed for conditional introduction. Okay, so then, we've assumed A and B. Focus on this subderivation, the second one, for just a minute. Having assumed A and B, what is the goal after that inside of that subderivation? We are trying to establish what information or part of this proposition up here in the scope of the subderivation. We have to orient ourselves towards the current goal, okay? We have assumed A and B, but for what reason? Because we do want to get to C. That's right. So we want to eventually get to C. How can we do it? Well, now you have to, I think, tell me more. What would you do on line 3? There's not 100 million different options. There's 10 options. So think about that, right? When you feel overwhelmed by all the rules, remember there's only like 10 of them, plus reiterations, so there's technically 11. But you can't do some of the rules, right? Like right now, you can't do disjunction elimination. It doesn't apply. You can't do, I don't know, biconditional introduction because there would be no point. So there's only a set specific range of possible rules that you can't even use now. So let's see if you can just tell me one valid inference to make on line 3. Even if you're not 100% sure why you're doing it, just use the inference rules in a way that you're allowed to do. So make an inference. Use one of the rules. Tell me what to do on line 3. Okay, Leo, so that's great. You're saying remove A from line 2 from using conjunction elimination. That's great. Let's do that. Everybody, can we all see what Leo said? This is a conjunction on line 2, which we assumed in order to try and build that conditional statement. Well, since it is a conjunction, we're free to take parts of it off. And so we did. We removed A, the left conjunct, using conjunction elimination. Conjunction elimination. Okay? So if you wanted to take A away from line 2, maybe you had a reason for doing that. And there is a logical reason to have A, because now we can make a new inference. What would that be? Can you see on line 4 what the next inference should be? Because we're hoping to eventually get to C somehow in here. And we're making some progress now. Okay, so Leo, you say B arrow C, and that's good. That's conditional elimination 1 and 3. Yes. Did I lose anybody here? Hopefully not, right? Look, where's line 4 coming from? Line 4 says B arrow C. Why? Well, it says that because on line 1, we have the if A, then this. And on line 3, we actually have A. So whenever you have the antecedent of an existing conditional, you can use it to eliminate the conditional. And that releases the information that follows on the right of that arrow. So we have B arrow C now, which is going to be very useful as we continue going through the steps in this problem. But we're not done yet. We're not done until this whole big crazy looking sentence is on the bottom line. So a few more steps remain. What about line 5? If all of you guys have watched what Leo just did with like line 3 and 4, then you should be thinking about something very similar that you can do next, but just with different parts of these sentences. So what about line 5? Someone give me an idea. another inference that still has yet to be done. Okay, Leo, you're really taking one for the team, as it were, right now. Come on, everybody, don't put it all on Leo. Get in there. Can we all agree and understand that B is another conjunct? B. You got to think about that. Just look at each line and exhaust all the possibilities, okay? So B is another one of the conjuncts. So we have now taken B down. And that's going to be based on what rule? It's the rule of conjunction elimination from 2. Now, Leo, don't you tell us what to do next. Someone's going to have to tell us what to do now that we have line 5, which says B. What do you think? Anybody else? Not named Leo. Okay, that's good, Karina. So you're saying C by doing conditional elimination from 4 and 5. Yes, correct. Okay, so what's next? We started with A and B here on line 2, assuming for conditional introduction, and everyone was telling me we need to get C, which we now did. So all you got to now say is like how to close the subderivation. That doesn't require any new inference or thought. It's just what's the procedure when you close the conditional introduction subderivation. You have to match the assumption made when you did introduction on the first line with the consequent that you established on the final line of the subderivation. So without telling you the exact letters, I'm telling you the method to use. Match the antecedent with the consequent. Yeah, well, I mean, what is that? For line 4, why is it 1 and 3 and not just 1? Because line 3 says A. Line 1 says A, then B, then C. So, I mean, you can't write just B, then C. You can't just take that off of line 1 unless you also had the antecedent. Brenna, conditional elimination always requires the citation of 2 lines. You can never, ever do conditional elimination and just write like line 2 or line 7. It's always 2 lines because you have to have the 2 things combined, a conditional and then just the stuff that's on the left. So for you to do conditional elimination on the statement A arrow B, you would have to have both A arrow B, but also on another numbered line, what other piece of information? Jessica, I'll get back to you. But Brenna, I must deal with your question so that you clearly understand. When you're doing conditional elimination, how many lines must be cited? 2. If you had a conditional that you were trying to eliminate and it said A arrow B, what would you need on another line before you could eliminate it? Brenna, tell me. If you had A arrow B and you wanted to eliminate A arrow B, what other line with a different information would you also need to have to do that? Brenna? You need 2 lines. Yes, you need 2 lines. So in my example that I'm currently mentioning, A arrow B is one of the lines. What should be the other line? If A arrow B is one of them, then you also need a second line which just says what? You have one line that says A arrow B. You're going to do conditional elimination. So you need both the A arrow B line and also a second different line. And the different line has to say what combined with A arrow B? Okay, don't worry. Well, let me just tell you, okay? If you have somebody else tell all of us. We have A arrow B. What do we also have to have on another line to close and to eliminate that conditional? Is it A? Yes, it's A. So you have to have these 2 things. If you had those 2, then on line 3, you could say B, conditional elimination 1 and 2. But you cannot ever do conditional elimination with just the conditional by itself and not the antecedent separate from that. Okay, so let's please keep that clear. Conditional elimination requires a citation of 2 lines. So you cannot write arrow E and 1 number ever. You have to write arrow E and then two different numbers. One of them has to be the conditional, and then the other number has to just be the number where the left part is. That's why when I was asking you just now, say you had A arrow B and you wanted to eliminate it. Yeah, you have to have A also on a different one. Okay. So back to the problem. We're on line 7. We're on line 7 right here. We started by doing conditional introduction, A and B. And through a number of steps, we got to C. So what is line 7 then? I think I see it above. Some of you have written it out. Jessica, I see that you wrote A and B, arrow C. Okay. And you say conditional 2 through 6, but it's not conditional introduction 2 through 6. What's the right rule to cite here? On line 7. Jessica, you have A and B, arrow C, that's good, but just the citation's just slightly off. The rule to give to justify this. It's conditional introduction 2 through 6, so good. Okay, actually, yeah, I do see you wrote it. I didn't see the letter I there for a minute. My bad, thanks. So A and B, arrow C. That is conditional introduction, line 2 through 6. Okay, now, A and B arrow C occurs within the scope of this assumption on line 1. And that was the whole game, to assume the antecedent of the big conditional and eventually arrive at the consequent, which we've done. So the only thing left to do is to finish the problem on line 8. So what should line 8 say? If it's the last line, then we already basically know what it's going to say. It's going to say the solution, but you can tell me. Go ahead. A arrow B arrow C was assumed. We thereby attained A and B arrow C. So we're done. Tell me what to write. Okay, Jessica, the big formula, and it's based on conditional introduction 1 through 7, correct? And that is conditional introduction 1 through 7. So this would be the answer for our problem number 7 of the homework. I say it's easy, and I say it is easy because it's just conditional introduction twice. It's conditional introduction assumption of this whole statement. Then, since you have to next prove the claim that's on the right of the arrow, you look at what kind of sentence that is, and you see that it's another conditional. So you have to do a second subderivation to build this conditional within the scope of this assumption. That means that you now assume A and B, the relevant antecedent here. That's what we do on line 2. Now the goal, internal to this subderivation, is to get C. So we see that line 2 is a conjunction. We disassemble it, remove A from it on the left. That's conjunction elimination. Now that we have A, we can use it, we do use it, to eliminate this conditional here. That's conditional elimination. And I really do say, go back, look at these rules, because we are way downstream. You have to know the rules. A is used to eliminate this conditional on line 1. That leads to the consequent, which is if B, then C. Note that B is the other conjunct involved on line 2. So a second use of conjunction elimination brings it down. Now B can be paired with B arrow C on line 4, thus allowing us to eliminate the conditional and get its consequent, which is C. So from the assumption of A and B, we have led ourselves to C. That is when we close this subderivation and we have A and B arrow C. Conditional introduction 2 through 6. Having obtained this statement on line 7, within the scope of this subderivation, we're now able to close the initial subderivation 2, and that produces the full sentence that we want at the end. So since the theorem took a little work, let me at least show you the opening of problem 8. And I'm not going to do like any help or assistance, but maybe we can get some idea of how to at least approach the problem. So so this is problem 8 from the homework, okay? And how would you do this? I'm not saying anything else. How would you solve that? If you say something correct, I'll validate it. If you say something incorrect, I'll invalidate it. But I won't say anything else. So if you want the answer, you guys have to help each other and come up with some information that I can agree with or disagree with. How would you solve this? Derive that. That's problem 8 of the homework. Assuming the antecedent, okay. What would that be? Okay, Leo, you say A and not B. Conditional introduction. Okay, I'm not even going to write it down, but I'll talk you through it, and you have the record of this chat that you can look back at later. So, all right, if you assumed A and not B to get it started, what would you then be doing afterwards? I could agree that that's the first step. But what would you do next? Anybody? On line 2. You seem to know how to get it started. You are looking for the consequent. Okay, good. Yeah, but what would it be specifically? So far, you're saying true things. You're saying you would assume for a conditional introduction A and not B. Yes. You're also saying then you would be looking for the consequent. Also, yes. But more specifically, what consequent? Okay, Leo. Well, yes. You're saying what the next inference would be. I was asking a more general question, which is just what would be the goal next, and you say consequent. The consequent overall is not just tilde C. The consequent of the big conditional is tilde C arrow tilde B. So you're a step ahead, because I think you understand that if you are going to establish this big formula, you're going to have to assume tilde C on the left for conditional introduction, right? So, to be clear, the first step is yes, assuming A and not B. After that, you have to engage with this consequent. But knowing that this consequent is itself a conditional, that will require the assumption of its antecedent. And then the whole game would be to try to get to what result within the second subderivation. Within that second subderivation, your new goal would simply be to find what? So like mentally, you have line 1, A and tilde B. Assume conditional introduction. Line 2, tilde C. Assume for conditional introduction. But what would be the goal sentence inside of the second subderivation? Yes, that's right. It would be tilde B. So I'm going to leave it with that. If you could solve it from those hints, then you should be in good shape. But you basically got most of it already given to you. You're assuming A and not B. You're assuming tilde C. And then you've got to find some way, I wonder what it would be to derive tilde B within that second subderivation. And from there, they will just close in sequence. You then have tilde C, arrow tilde B, and then that would close the larger subderivation in one more step after that. Okay, so we can go on from there. Maybe maybe there will be a chance to take another look at one problem or so on Wednesday, but I want you guys to be able to work through some of them on your own, of course. So at this point anyway in class, we've discussed, I guess, number 1, number 10, for sure number 7, and we've gestured a little bit towards number 8 here. And as always, I invite you guys to make full use of all the resources that we have, right? So one of those resources is just me and my office hours. You're always free to do that. Oh, you mean this problem? Let me just think. Okay, so this will be, let's see, iteration is 3rd step, 4 or 5. It's like 5 steps. It's 5 steps. We're pretty sure it's just 5. It's 5 steps. It's 5 steps. Okay? No problem. So yeah, I was just saying that we did all these certain number of practice problems from the homework or the actual homework problems. And in 1 week, that homework problem set is due. So in between now and then, you can make use of the office hours that I hold on Mondays and Wednesdays from 1:30 to 2:30. If those times don't work for anybody and they would like to have a Zoom opportunity, then please let me know and I could arrange some alternative time that's, you know, agreeable to both of us. It is due on Monday, by class time on Monday, December 7th. So that's a week from today, no later than 11:30 a.m., just as an email attached file to me. So you still have a week to do it. It's not that it's imminent, but you know, logic problems and stuff, they're better not to do at the very last minute because it's easy to get lost or confused when you're pressured by time. So I would advise you to try and do it in a more leisurely, spread out way. But of course, you'll do your best, and I'll just see what your results are. But yeah, it's due in a week. There's also our logic tutor. I've sent an announcement to you guys a while back about Danielle Batali, who's our Cal State Fullerton logic tutor. And she works for us, and she's happy to help anybody with any of these problems. So you do have to seek her out, but if you want, go back into our announcements tab from our class, and you'll see the info that I provided for her from earlier in the semester. So, you know, if that's another way you can get some assistance aside from just me. There's always the selected exercises in the workbook that they provide answers to if you go to the online solutions center for the logic book too. So that's just some general information about how to prepare for that upcoming homework problem. Okay, so next of all, let's take a quick look at this problem from the homework. Not from the homework, sorry, from problem 5.3.F in the book. That's on page 209. So just a quick practice problem, something not too hard. Okay, so try to derive that if A, then if B, then D. And your only assumption is D. Okay, so how would you start this problem off? This is problem page 209, 5.3, letter F. So that's all we've got so far. We just have D, and we need to build this conditional. So let me start by a question. Oh, sorry, Jamie. Do we have to email her, or does she have office hours? I'm not 100% sure how she organizes her availability, but I believe that she's free to do Zoom meetings or email exchanges throughout the week. She's, I think, got designated times, but I'm not 100% with a clear memory of when they are during the week. But she emailed me last week to say that she was out for the Thanksgiving holiday and that she was back in today. So simply do email her, and you'll be able to follow up with her on all those details. Sorry that I don't have them top of my mind right now, but it's all included in our announcements. So if you go back, you'll see it then. To this question, though, you have to derive that A arrow, B arrow, D. What kind of sentence? No problem. So what kind of sentence is this that you have a goal to derive right now in this problem? You need a what type sentence? The current problem. It's a conditional. Very good, Arlene. Yes. So if you need a conditional, you should first think of what rule. The rule is known as what? Conditional introduction, yes. So if we're going to do conditional introduction with the goal of building this conditional, what must we do? Just tell me what inference to make then on line 2. For this conditional, for this conditional introduction, specifically, we have to now assume something. So tell me how to do it. The rule of conditional introduction, it's always the same. I mean, it never changes. So it's just, yeah, you assume whatever's on the left of an arrow. In this case, it's A. We've assumed A, but why? Because now we have a new goal. Inside of this subderivation, we're trying to build to what? What is the goal internal to the subderivation that begins on line 2? We start with A on line 2, and where are we trying to get to in the end? From A, we wish to establish what information? How does conditional introduction work? You assume an antecedent, and then the goal becomes to prove the what? There's like two sides of these arrows. There's on the left side, there's on the right side of the arrow. When you do conditional introduction, you assume the left side of whatever arrow statement you're trying to get. And then after that, your goal becomes the stuff that's on the right of the relevant arrow. In this case, yes, Jessica, B arrow D. So if B arrow D is the new goal, question, what type of sentence is B arrow D? What kind of sentence is that? Second one now that we're mentioning. Yes, it's another conditional. So if we're going to find B arrow D here somehow, we're going to have to build it ourselves. And that means that we have to now again use what rule? Line 3 should show that we're going to use what rule again? That's all you. You got to tell me. Conditional introduction, good. So be specific. What's the assumption of conditional introduction on line 3? Tell me the whole thing. Like, what's the sentence and the rule? It's not A. Well, okay, sorry. If what you mean is assume for conditional introduction, yes, that's true, Arlene. But assume what for conditional introduction? On line 3. Good. Good, Jessica. B is assumed here for conditional introduction. Because B is the antecedent of this part. So this part is all that we're trying to build interior to line 2 subderivation. That means that we must do yet another subderivation involving B. And what's the goal within this second subderivation? We're assuming B in hopes of obtaining what below it? What statement are we now trying to get to? So we start with just D is a given. A we assume for conditional introduction to find this. B we assume for conditional introduction, and now to get what? To get D. Very good, Jessica. So how can I find the letter D and place it inside the current subderivation? Very good, reiteration. Line 1 is an assumption that we've been provided with, and it says D. So we can simply reiterate it down here. Okay, so what's line 5? What's line 5? That's something that I don't want to tell you. Just tell me, what is line 5? I'll explain it afterwards, but you can please tell me first. Okay, Arlene, B arrow D. Very good. Conditional introduction 3 to 4. Okay, we're almost done. What's line 6? What is line 6? Notice that line 2 assumes A, and whatever this stuff is on line 5. So, I mean, what's next? I mean, you could see that this line 5 comes from the closure of the subderivation that starts with B and ends with D. So now if you widen your scope to this subderivation that begins with A, and on line 5 we have this question. That is from conditional introduction, line 2 through 5. And so that would be the solution on this problem. So where is this coming from on line 6? It's coming from the fact that we assumed A, and we were able to prove through a series of steps B arrow D. Conditional introduction is you want to build a conditional. You've been told what it is. You've been told that it's A arrow something. So all you know is that I have to assume the A part, and then I'll find the whatever's the something on the right side of this arrow eventually. Knowing that this is the thing that's on the right side of the arrow, this becomes your new goal once you've assumed A. But look at that, that's a conditional. So another sequence of conditional introduction has to be used to establish this claim. So since this claim, just looking at it by itself, is B arrow D, the method involves assuming B and proving D afterward. So we assume B, and if you just look back, you'll see that D is already there on line 1, so it's available to be reiterated into line 4. B was assumed, D was obtained. That closes this subderivation right off, and it gives us B arrow D. Now B arrow D is sitting inside this subderivation that started with A. A led to B arrow D. We thus close conditional introduction, and when you close conditional introduction, what the result is a conditional. It's a conditional which joins the initial assumption that you made with the final conclusion that you arrived at below. In other words, A linked by an arrow to B arrow D. And that's the problem there. So basically today I wanted to drill you a little bit on two things. First of all, I wanted to give you kind of freebie on the homework and do one that was tough. That's the last one. But I also wanted to give you some more engagement and familiarity with conditional introduction, which we did both in the theorems, problem 7 and 8, and in this problem here, problem F from page 209. So just know that these rules are not going anywhere. You have to be comfortable with them. You have to be able to do conditional introduction and conditional elimination, negation, introduction, elimination, disjunction, introduction, and elimination. And the rules all come into play at various points depending on the needs of a particular problem or proof. So that's about all I have time for today, but when we come back on Wednesday, we'll just do more of the same. We're going to work on some more of these derivations, and practice makes perfect. I'm trying to get a lot of the practice in during class because I know people with busy schedules and everything might not be able to do a million practice problems on their own, but you should do as much as necessary for you to feel confident and familiar with the basics of these inference rules. And again, if you need any help or assistance, guidance, whatever on the homework problems, just let me know and I can try and help you through some of the difficult parts if there are any. All right, guys, so for now then, that's enough for today's Monday meeting. I'll see you back then soon on Wednesday, and as always, I have my office hours 1:30 to 2:30 on Monday and Wednesday. If anyone wants to meet at a different time for any reason, please let me know. We can make an appointment for something otherwise. All right, guys, so take care. Thanks again. Hope you had a great holiday, and I'll be seeing you soon. All right, bye-bye.